I was reading a thread on a developer forum the other day about this valley of death in hardware startups.
Oh, yeah.
And it wasn't about running out of venture capital or bad marketing or even a bad idea.
Let me guess. The leap from prototype to production.
Exactly. It was about that brutal transition from it works on my desk to it works in the real world.
Oh, the classic prototype trap. It's a tale as old as engineering itself.
Right. It's that romantic image we all have of the lone genius in a garage. You solder a Wi-Fi chip to a coffee maker, you write, 10 lines of code, and boom, you can turn it on from your phone.
It feels like magic.
It feels like you're done. But then you try to sell 10,000 of them.
And suddenly, that magic turns into a logistical nightmare. Because when you have one device, you don't care about database latency.
Nope.
You don't care about concurrent connections or secure firmware updates or what happens if the Wi-Fi drops for 30 seconds.
But when you have 10,000 units in the field,
you aren't building a coffee maker anymore. You're effectively running a telecommunications company.
that is the perfect context for today's deep dive. We are looking at a platform called Favoriot. And based on the documentation we've been combing through, their entire pitch is basically, please, for the love of sanity, stop trying to build your own infrastructure from scratch.
It's a plea for efficiency, really. Favoriot creates what we call middleware for the Internet of Things.
So if you imagine your sensors, the hardware on one side of a massive canyon,
And your user dashboard, the app on your phone, on the other side.
Favoriot is the bridge.
It is the bridge. The documentation uses the term glue, which I think is visceral, but middleware is probably a professional term.
Glue works too.
It does, but it's structural glue. It handles the data collection, the storage, the security layers, and the device management. The goal is to free you up, the developer, to focus on what they call the vertical application.
Okay, let's pause on that term, vertical application. It sounds a bit like business school jargon. What does that actually mean for the guy in the garage?
It just means the specific problem you're trying to solve.
Oh, okay.
If you're building a flood warning system for a smart city, your value to the world is the algorithm that predicts the flood and alerts citizens.
Your value is not in writing the code that authenticates a database user.
Or manages server load balancing, exactly. Favoriot is saying, let us handle the boring plumbing, you focus on the water.
Okay, I buy the premise. Plumbing is expensive and hard to fix if it leaks. But I want to see how this actually works in practice. Because middleware can be a very abstract concept.
It can be, yeah.
If I'm that developer with the flood sensors, what is the first thing I'm doing in Favoriot?
You're organizing the chaos. This is one of the strongest parts of their documentation, the Favoriot platform hierarchy.
I feel like most people would skip this part.
They do, and it's a fatal mistake. They just start connecting wires.
But you need a filing system before you start generating paperwork.
Exactly. So Favoriot uses a strict 4-level hierarchy to keep things sane. At the very top, you have the project.
So using the smart city example from the notes, the project is the big umbrella.
Yes. Smart city management is the project. It's the container for the entire initiative.
Got it.
Under that, you have the application. This represents a specific functionality or, a specific interface. So within the Smart City project, you might have an application called City Operations Dashboard.
Okay, so project is the initiative, application is the tool people look at.
Correct. Then you get to groups, and this is crucial for management.
Because you don't want your sewage sensors mixed in with your traffic lights.
That's a recipe for disaster. So you group them. You might have a group for downtown district or water quality management.
And finally, inside the group, you have the device.
The physical sensor itself, traffic light 04 or air sensor 09.
So why does this matter? It's not just for neatness.
Not at all. It's for control. When you want to push a software update or change a setting, you don't want to broadcast it to the whole smart city.
Right.
You want to push it only to the traffic light group. Without this hierarchy, you're just throwing code into a void and hoping it lands on the right chip.
That makes sense. It's about limiting the blast radius.
Yeah.
If you mess up a configuration, you only want to mess up one group, not the whole city.
Precisely. It turns a chaotic swarm of gadgets into a structured fleet.
So we've got our buckets. We have the hierarchy set up.
Yeah.
Project, app, group, device. Now we need these devices to actually speak to the platform. And this is where I usually get a headache because hardware manufacturers love their proprietary standards. Does Favoriot force you to use a specific language?
No, and that's key. They take a very agnostic approach. They support the big 3 protocols. REST, MQTT, and COBIT.
Okay, let's break those down because I think a lot of people know the acronyms, but maybe not why you'd pick one over the other in this specific ecosystem.
Good idea.
Start with REST.
Okay, so REST is the language of the web. It uses standard HTTP requests, GET, POST, PUTI.
Right.
In the context of Favoriot, the documentation suggests using REST primarily for the management side.
Ah, so for the dashboard.
Exactly. If you're building that web dashboard for the city mayor, your website is going to use REST API calls to ask Favoriot, hey, give me the list of all devices in the downtown group.
Okay, so REST is mostly for the humans and the browsers. It's request and response.
Very much.
But what about the sensors? I keep hearing that MQTT is the king of IoT.
It is, and for good reason. REST is a bit heavy.
Yeah.
It requires a lot of back and forth handshaking for every single message. MQTT is lightweight. It's designed for devices that might be running on a battery in the middle of a field with terrible cell reception.
Uses that publish and subscribe model, right?
Exactly.
Pub sub.
The notes mention something called QO, quality of service, regarding MQTT. It sounded like a menu option. Level 0, 1, or 2? Is this just marketing speak? No, it fundamentally changes the behavior. Think of it like a shipping guarantee. QoS level 0 is fire and forget.
Okay.
The sensor throws the data at the server and doesn't wait for a reply. It's fast, but if the internet hiccups, that data is gone forever.
Which might be fine if I'm updating a temperature reading every 5 seconds. If I miss one, who cares?
Exactly. But then you have level 1, at least once.
So it's guaranteed.
The sensor keeps sending the message until the server says, I got it. You're guaranteed delivery, but you might get the same message twice.
And level 2.
Exactly once. It involves a complex 4-step handshake to ensure the message arrives and is only processed one single time.
So it's the safest, but uses the most data.
And battery. So Favoriot supporting all three is actually a big deal because it lets you choose. Do I care more about speed or accuracy?
That's a great distinction. If I'm measuring temperature, I choose speed. But if I'm sending a fire alarm signal...
You definitely want QoS2 for the fire alarm. You don't want to fire and forget a fire alarm.
Then there's the third one, COAM. It sounds like a mispronunciation of a cough.
It stands for Constrained Application Protocol. If MQTT is a motorcycle fast and Light CoAP is a bicycle.
A bicycle.
It's designed for the absolute tiniest devices. I'm talking about microcontrollers that have almost no processing power and are running on a coin cell battery. It has incredibly low overhead, even lower than MQTT.
So Favoriot is basically saying, bring whatever you have, we speak the language.
Right. Whether it's a Raspberry Pi, an Arduino, or a tiny ESP32 chip, they have a protocol that fits the hardware constraints.
Now, speaking of connecting things,
Yeah.
anytime we talk about putting city infrastructure on the internet, I get a little nervous.
As you should.
We've all seen the movies where the hacker turns all the traffic lights green at once. How does Favoriot prevent that scenario?
Security is layered into the connection. Obviously, they use standard encryption HTTPS and secure MQTT using certificates. But the real protection, the part that impressed me in the docs, is in the key management.
They distinguish between API keys and access tokens, right?
Yeah. Yes, and it's a vital distinction. API keys are for the application level. You have read-only keys, which you might give to a public dashboard, and read-write keys.
The ones that let you delete things.
Yes. The
Yep.
ones that allow you to delete devices or change settings, you guard those read-write keys with your life.
And the access tokens?
Those are for the devices. Every single sensor gets its own unique access token. It acts as its username and password.
Why is that better than just using one password for the whole fleet? I mean, it sounds easier to just hard code one password into every device.
Easier, but catastrophic. It comes down to compartmentalization. If someone physically rips a sensor off a lamppost and hacks it to extract the password, they only steal that specific access token.
So they can only impersonate that one device.
Right. They can maybe send fake data for that one street corner, but they can't access the rest of the network. They can't bring down the system.
It's the difference between stealing a hotel room key and stealing the master key card.
Exactly. If you lose a room key, you just cancel that one key. The hotel keeps running.
Okay, so we have the structure, the language, and the security. The data is flowing in. Now, what do we do with it? This is where we get into the brains of the operation.
Yes.
The notes highlight Rules Engine 2.0.
This is where IoT moves from just monitoring to actual automation. And the 2.0 is significant because it marks a shift to a visual workflow.
I looked at the diagrams for this in the source material. It reminds me of those if this then that tools.
That's a good comparison.
You aren't writing code, You're dragging blocks around on a screen.
It's a node-based editor. It makes the logic visible. You connect different nodes with lines to create a flow. They categorize them into 4 buckets: input, filter, function, and external.
Walk us through a real scenario. Let's go back to our smart city, maybe a heat wave emergency. How do you build that without writing code?
Sure. So you drag an input node onto the canvas. This is a stream listening to your temperature sensors. Let's say a reading comes in, 40 degrees Celsius.
That's what, 104 Fahrenheit? That's definitely an emergency.
Very hot. So that data flows down the wire to a filter node. You've set a condition there. Is temperature 35?
In this case, yes, it passes.
So the gate opens. If it were 30 degrees, the flow stops right there. But it's 40, so it passes through to a function node.
What would that do?
Maybe your emergency response team operates in Fahrenheit, so you use a unit converter node to swap the math.
And then?
Then it hits the external node. This is the action. You can drag in an email node or a telegram node to blast an alert to the city manager saying critical heat warning.
What I found cool was the idea of parallel execution.
Right. It's not a single line. That one temperature reading can split into 3 branches simultaneously.
So branch A sends the telegram alert.
Branch B saves the data to a specific history database. And branch C, and this is the cool part, hits a control node.
Control, what does that do?
It sends a command back to the device. So automatically, without a human lifting a finger, the system sees 40 degrees and tells the HVAC system in the public library to turn on the AC.
So it's bidirectional. It's not just listening, it's reacting.
That is the definition of a smart system. If it just records data, it's a logbook. If it reacts, it's a smart system.
Oh, wait, there's reacting, and then there's predicting. And this is where the documentation got really sci-fi. Favoriot has a built-in machine learning engine.
This is the crystal ball. Usually, if you want ML in your IoT project, it's an integration nightmare.
Yeah, you have to export your data to Amazon or Google, train a model there,
and then somehow pipe the answers back. It's a mess. Favoriot built the ML engine right into the platform.
And they claim it's simple configuration.
It's designed for developers, not data scientists. You don't need a PhD in statistics. You pick your data source, you pick an algorithm, and you hit train.
What kind of algorithms are we talking about?
There are 3 main flavors. First, time series forecasting.
Okay.
Think of this for energy usage. Instead of the AC turning on after it gets hot, the system looks at historical data and predicts it's going to be hot at 2 p.m., so it pre-cools the building.
That saves money.
Huge amounts of money. Then you have unsupervised learning, which is great for anomaly detection.
Is that like finding a needle in a haystack?
It's like finding a machine that's about to break. Let's say you have water pumps. You don't know what a broken pump looks like mathematically.
Right.
But the algorithm learns what a normal pump looks like. If one pump starts vibrating just slightly differently, an anomaly, the system flags it before it fails.
That's the difference between scheduled maintenance and run to failure.
Exactly. And the third type is supervised learning for classification, teaching the system to recognize specific states like leak detected versus normal flow, based on labeled data you've given it in the past.
Now here's the feature that I think is the real game changer. The notes call it offline inference.
Yes. This is where we blur the line between the cloud and the edge.
Explain this to me. Because usually AI lives in the cloud, right? You need big servers to run those brains.
To train the brain, yes. You need the horsepower of the cloud to crunch the historical data and learn the patterns.
Well, once it's learned.
Once the model is learned, it's actually just a mathematical file. Favoriot lets you download that brain.
You download the AI.
You download a .pkl file, that's the model, and a .joblib file, which is the scaler.
Okay, I stumbled on that in the notes. What is the .joblib scaler? Why do I need that?
Think of the scaler as a translator. When you train an AI, you usually normalize the data. You squash all the numbers so they're between 0 and 1, for example, so the math works better.
Wow.
The scaler is the rule book for how you squash that data. If you don't have the scaler, the device won't know how to format the new live data for the brain to understand.
Got it. So you take these 2 files, the brain and the translator, and you load them directly onto your Raspberry Pi or your gateway.
Yes. So now the traffic light doesn't need to ask the internet what to do.
It has the intelligence locally.
Exactly. Even if the internet goes down or the server crashes, that device can still predict traffic patterns and adjust the lights in real time.
That is huge for critical infrastructure.
Yeah.
You can't have a flood warning system that fails just because the Wi-Fi dropped.
It creates a resilient system. It uses the cloud for what the cloud is good at, heavy lifting and history, and uses the edge for what the edge is good at, speed and reliability.
We've covered the deep tech, but we should touch on the tools that keep this ship sailing.
Right.
Because if I have 500 devices, I am not visiting them one by one to update the software.
Firmware OTA over-the-air updates. This is a non-negotiable feature for any commercial IoT product.
But it's also risky, isn't it? Bricking a device.
Yeah.
If the power cuts out while I'm updating the firmware, that device is dead.
It's the developer's worst nightmare. Favoriot handles this with a chunk-based approach over MQTT. They don't just dump the file.
They break it up.
They send a start marker, then they stream the binary file in small, manageable chunks, and then an end marker.
So if it drops a packet in the middle,
The device knows it missed a chunk and can request it again or cancel the update safely. It prevents that dreaded bricking scenario where the device gets half a brain and then dies.
and there was also a mention of an edge gateway. How did
Yeah.
that fit in?
The edge gateway is the bridge for local devices that can't talk to the cloud directly. Maybe you have sensors using Bluetooth or LoRa. They don't have IP addresses.
I see.
The gateway talks to them locally, aggregates that data, processes it, and then shoots it up to the Favoriot platform via MQTT. It's another layer of flexibility for complex environments.
And finally, for the people who just want to see the pretty charts dashboards.
Can't forget the eye candy. Drag and drop widgets, graphs, gauges. But the smart feature here is the public dashboard. You can generate a shared URL.
So I can show the citizens the air quality data without giving them my login password.
Exactly. Transparency without security risks. You create a view, generate a link, and tweet it out.
So if we zoom out, looking at Favoriot as a whole, it feels like they've identified every pain point that makes developers quit IoT projects.
The infrastructure, the protocols, the security, the ML pipeline, the updates.
They're saying, we did the boring hard stuff.
Gotcha.
You go save the city.
It really is about enabling that vertical application. If you are building a smart agriculture solution, you should be worrying about soil moisture and crop yields,
You shouldn't be staying up at night worrying about SSL certificates.
our database sharding, and
Oh.
API token management. Exactly.
For anyone listening who is itching to try this, maybe you have a Raspberry Pi collecting dust in a drawer, the documentation points to a tutorials section.
It's very robust. They have guides for everything from basic connection to real-time face detection projects. And definitely check the redeem voucher section if you sign up.
Good tip.
We all love a discount on subscription plans.
I want to leave everyone with one thought.
Right.
We talked about offline inference, taking that cloud brain and putting it into the device. I think that's the future. We are moving away from smart devices that are just remote-controlled puppets and toward devices that actually think.
Decentralized intelligence. It's a fascinating shift, and platforms like this are making it accessible to everyone, not just tech giants.
It connects the dots between the garage and the smart city. Thanks for helping us break it all down.
My pleasure.
And thank you for listening. Keep building, keep connecting, and we'll see you in the next deep dive.